Hello guys, welcome to this new video. In this opportunity I want to solve a problem that is already a known problem and is really easy, but I want to do something with this. The problem is an electron projected with initial speed v0 into a uniform field between two parallel plates that I will show you in the next page. We want to assume that the field between the plates is uniform and directed downwards. The electron enters the field at a point midway between the plates. The part A is if the electron just misses the upper plate as it emerges from the field, we want to find the magnitude of the electric field. The part B is suppose that in the figure the electron is replaced by a proton with the same initial speed v0. Would the proton hit one of the plates? If the proton would not hit one of the plates, what would be the magnitude and direction of its vertical displacement as it exits the region between the plates? The part C is we want to compare the paths traveled by the electron and the proton. And the part D is we want to discuss whether or not it is reasonable to ignore the effects of gravity. Okay. Let's go and see the illustration of this problem, and we have something like this. Okay guys, we have here the figure where the electron enters the region between the plates. As we can see here, the electron enters the region horizontally with initial speed v0. The electron at t equals 0, the electron is at the origin of coordinates x0, y0, and also we can see right here that the electric field is pointing downwards in between the plates. Okay guys, so for an electron, the force that it experiences is given by this following formula. F is equal to Q multiplying the electric field. Here we have the following. F if the electric force, okay? E is the electric field between the plates. And Q is the charge of the particle, in this case is the electron. Alright, the electron is represented by the minus E notation for its charge, okay? So we can write the charge Q as minus E, where E is the charge of the electron. Okay, then we can write this little equation like this. F equal to minus E multiplying E. Alright, so this force is going to be a quantity that it will depend on the sign of the charge. Because E is a negative quantity, as we can see right here, because E is a negative quantity, as we can see right here, the electric force and the electric field will have opposite directions, okay? So F for the electron is pointing outwards. F for the electron is pointing outwards, but E is pointing downwards, as the problem is stating, okay? So if we have an electron inside the region, we can draw the free body diagram for this particle like this. We have the electron, this is the force that is acting on it, F equal minus E multiplying the field E, and this is the, obviously, this is the x-axis, and this is the y-axis, okay? The acceleration of the electron is this vector right here, okay? So let's write the second Newton laws for this particle. So according to the second Newton's law, we have summation of the forces on the y-axis is going to be equal to the mass of the particle. In this case, it's the mass of the electron multiplying the acceleration of the electron, okay? We already know that the force that the electron is experiencing is equal to minus E multiplying the electric field, okay? Then we can replace this expression into this equation, and I will have something like minus E multiplying the electric field is going to be equal to the mass of the particle multiplying its acceleration. So let's have this equation right here written, and I will call this equation equation number 1. Now we want to solve the kinematics of the electron inside the field, okay? We want to do that because we want to find a new parameter here, but first we want to write the equation of motion of a particle that is moving with between it on a plane. So the component x of the motion is equal to x0 plus v0 along the x-axis multiplying the time plus 1/2 of the acceleration along the x-axis multiplying the time squared. Okay? Let's call that equation number 2. Let's call that equation number 2, but we have here, according to the problem, some initial conditions, okay? If we remember the initial conditions of this problem, they are, for example, the initial position along the x-axis is x0, right? But we already know that the particle started its motion at the origin of coordinates, as is shown right here on this illustration. So at time t equals 0, the position of the particle is x0 equals 0 and y0 equals 0. That's the origin of the coordinates of the system. So we have here x0 equals 0. We also have x like the total displacement along the x-axis right here, but we already know, so the problem is giving this information to us. The distance or the length of the place is 2 centimeters, like is shown here. Okay, 2 centimeters, like is shown right here. Okay, so we write right here that the distance that the particle travels along the x-axis is 2 centimeters. And if we do a conversion real quick, we will find out that 2 centimeters is equal to 0.02 meters. It's something really easy to do. It's just dividing this quantity by 100, because you know 1 meter is equivalent to 100 centimeters. So we want to divide the 2 centimeters by 100, and that way we have this quantity expressed in meters. Okay. Also, we have that the initial speed along the x-axis, according to the problem, is 1.6 times 10 to the 6th power meters per second. Okay, that's the information that we have. We want to find the time that the particle travels along the x-axis. I mean, it's the same time that the particle travels to exit the region between the plates. So we don't know that time. That is an information that we want to calculate. Okay, because the particle is moving along the x-axis with constant speed, that means that the speed is not changing at any time along it travels along the x-axis. Along the y-axis, the situation is different, but we will talk about it later. So the acceleration along the x-axis is equal to 0 as well, because the motion is constant along the x-axis. It's the same speed all the time along the x-axis. So the acceleration is equal to 0. We want to replace all these balls into equation number 2, and we will have the following. S is equal to 0.02 meters. X0 is equal to 0 plus B0x, we know that is equal to 1.6 times 10 to the 6th power meters per second plus 1/2 of the acceleration Okay, multiplying the time plus 1/2 of the acceleration, but we know that the acceleration is 0, multiplying the time squared. So this term is 0, this term is 0 because it's multiplying by 0, and this is equal to 0.02 meters equal to 1.6 times 10 to the 6th power meters per second, multiplying the time. All right, I want to clear this term. Okay, I want to clear this term. What I do is I take this expression and send it to the other side of the equation dividing. So we have t equal to 0.02 meters dividing 1.60 times 10 to the 6th power meters per second. This meter cancels this meter, and this second goes to the numerator of this expression, and this is equal to 1.25 times 10 to the minus 8th power seconds. So the time that the particle travels inside the place is 1.25 times 10 to the minus 8th power. Okay guys, this is the time that we wanted to find. Okay, that's the time that the particle spends to travel. Okay, horizontally the distance 0.02 meters, but in this same period of time the particle travels the y distance, I mean the vertical distance along the y-axis, and the problem says that that distance is y equal to 0.50 centimeters. And we can do the same that we did earlier, because we want to find this expression, or we want to write this expression in meters. So it would be dividing this quantity by 100 to have this quantity in meters, and that is equal to 0.005 meters. Okay guys, and that's the distance that the particle travels vertically. Let's go to the illustration real fast. The particle enters, right? Enters the region. So the particle travels this distance along the x-axis. Okay. I will use a different color real fast. Red color. The particle travels this distance horizontally, and it spends the 1.25 to the minus 8th power, right, seconds. But at the same time the particle is moving vertically. Okay, and that's the same time. So the combination of the horizontal motion and the vertical motion is this path that the particle is describing, and it's actually a parabola, right? Because the shape of the path is showing us that it's a parabola, but not only the shape. We can see that it's a parabola, but I will show you that on the next step, because the expression of the equation, the form of the equation, will tell us that this is a parabola. Okay, so okay guys, now we need to take into consideration something. we need to take into consideration that the y component of the motion of the electron on this problem. So we want to write the equation of motion of a particle that is moving along the y-axis, okay, under an acceleration, and we want to write this equation: y equal to y0 plus v0 along the y-axis multiplying the time plus 1/2 of the acceleration along the y-axis multiplying the time squared. This is the equation of motion of a particle moving along the y-axis. Okay, according to the problem, we have, as we did earlier with the component x, we want to do the same with the y component. The y component, we want to take into the consideration the initial conditions of the problem. So according to the problem, we have the distance that the particle travels along the y-axis is this. Okay, is this 0.50 centimeters, but we already know that in meters is 0.005 meters. Okay, so according to the problem, the vertical displacement of the particle is 1.005 meters. Okay, the time traveled by the particle, we calculated this time on the previous step, on the previous calculation, right? So that time is equal to 1.25 times 10 to the minus 8th power seconds. It's a really short period of time. So this problem is kind of, it's a kind of idealization. It's not really a real problem of the real life, because we are treating an electron like a classical particle, and an electron is not a classical particle. It's like, in reality, it's a quantum particle. The behavior of the electron is totally different, like this. It's totally different than the situation that we are showing here, but we are doing this problem like as an illustration anyways. We don't want to talk about it. It's not the scope of this problem. Okay, let's go forward and see. We want to calculate the acceleration. We don't know. Okay, along the y-axis. Okay, let's talk about something. The initial speed, the initial position along the y-axis is 0, because the particle started from the origin of coordinates, as you know. Also, the initial speed along the y-axis is 0, because the particle started its motion to enter the region between the plates with purely horizontal speed. Okay, so as is shown here. Okay, so the velocity along the y-axis is 0 plus 1/2 of the acceleration multiplying the time squared. Okay, the particle experiences a force along the y-axis. Why? Because, the particle enters this region. Okay, and there is an electric field That electric field deflects the path of the particle. Its trajectory is not going to be as is shown on the illustration. If there, let's suppose that there is no force. If there is no force, when the particle enters the region horizontally, it will leave the region at this same position, so it will travel just horizontally. Let me do something. I think that I am writing too many things here. I don't want to right here, but anyways, if there is not force, the particle is gonna travel just horizontally because there is no force. The particle is not experiencing any deflection on its path, but because there is a force, the particle is changing its trajectory over the time, and is doing this, and the particle won't do that unless there is a force that is deflecting its path. So there is a force, and because there is a force, there is an acceleration, because the second Newton law says that when you have a force applied on a particle, you will have an acceleration on that particle. Of the other way around, if the particle is accelerating, it's because there is a force that is being applied to it. So we have an acceleration. That's the point of this problem. Then this equation is going to be something like this: y equal to 1/2 of the acceleration multiplying the time square. Let's find that acceleration. So we want to find that acceleration. Let's go here. So let's find that acceleration. Acceleration along the y-axis is equal to, okay, I send this 2 to multiply and this time squared to divide, and I will have 2y dividing time squared, and this is equal to 2, but the y is given by this term, 0.005 meters. All that is dividing 1.25 times 10 to the minus 8th power seconds square. If we put all this into the calculator, we will find that the acceleration along the y-axis is equal to 6.40 times 10 to the 13th power meters per second. Okay, let's call this equation number 4. Okay, I forgot to write this and call this equation number 3, and I want to call this number 4. Okay, this is not really an equation, it's already a result, but anyways, I want to call it number 4. Okay, let me highlight it real fast. Oh my god, oh my gosh. Okay, that's the result of the acceleration. Then we remember that the acceleration is produced by the electric force, right? Because the second Newton law. There is a force, then there is some acceleration. And we remember this equation, oh my god, here, number 1. Oh my god. I am freaking out with these pens and oh my god, here. Yeah. Oh, sorry. Okay. Oh my god, I want the green, the black one. We remember this, okay? Let's write that right here. Minus E multiplying the electric field is equal to the mass multiplying the acceleration. Okay, the electric field is on the y-axis, so the acceleration is going to be on the y-axis because the force is on the same axis, okay? So let's, we can clear the electric field and we can write something like this. The mass of the electron is equal to 9.109 times 10 to the minus 31st kilograms, and its charge is 1.62 times to the minus 19 coulombs. Okay, I have, let's take something into consideration. The charge is negative, okay, and I have the negative sign right here already, and right here. So, but if you don't want to write the sign, you need to take into consideration the sign right here. So, but I already wrote the sign on the equation, but that's fine. I mean, it's just convention and it's the way you want to do it. So we don't have to make a big deal with this, but just to take into consideration. So we want to write this equation like we want to replace these terms into the equation number 1, that is this, and we already know the acceleration, right? That this was calculated on the previous step. Then we have E equal to okay, I forgot to write the minus sign. Okay, and we have here the mass of the electron is 9.109 times 10 to the minus 31st power kilograms, multiplying okay, the acceleration. All right, the acceleration is, according our calculations, is this one, 6.40 times to the 13 power meters per second. Square dividing the charge of the electron, 1.602 times to the minus 19 coulombs. All that is equal to minus 364 newtons per coulomb. That's the electric field. minus 364 newtons per coulomb. Okay, what is the meaning of the minus sign? What is the meaning of the minus sign? That means that the electric field is pointing downwards, and that is something that the problem already stated. Okay, we should know that the acceleration produced by this electric field is much larger than the acceleration of gravity. Why I am telling that? Also because the acceleration of gravity is the acceleration of gravity is 9.81 meters per second squared. But the acceleration of this electron is 6.40 times 10 to the 13th power. So the acceleration of this electron is really higher than the acceleration of the gravity. It's much higher. It's really much higher. So, and what I'm telling that is because we want to neglect the acceleration of gravity on this problem. And I think that that is already answering the part D of the problem. I mean, I don't want to skip, the steps when we are solving this kind of problems, but if we read the part D, we haven't resolved the part B and C yet, but let's see the part D real fast. Just take a second to do that. Discuss whether or not it's reasonable to ignore the effects of gravity. Yes, it is, because the acceleration of the electron is 13 orders of magnitude higher than the acceleration of gravity. I mean, it's something that is really higher, a lot. It's way higher, so it's totally neglectable. So it's reasonable to neglect the effect of gravity on this problem. So we already answered the questions, but anyways. So let's go to the big part B of this problem. Suppose that in the figure, the electron is replaced by a proton with the same initial speed v0. Would the proton hit one of the plates? So we on the part B, we don't have an electron, just we replace it for a proton. If the proton would not hit one of the plates, what would be the magnitude and direction of its vertical displacement as it exits the region between the plates? Okay, let's do that part B real fast. So we want to suppose that the electron is replaced by the proton with the same initial speed, right? So let's use equation number 5. Okay, so but I want to write that equation like this. So we have minus E multiplying E equal to the mass multiplying the acceleration. Okay, so we suppose that the electron is replaced by a proton with the same initial speed. Let us this equation and use that equation to find the acceleration of the proton. So we need to take into consideration that we already changed a proton for an electron, so this charge is positive because the proton has positive charge. The electron has negative charge, but the proton has positive charge. So let's clear the acceleration of that equation, and we have E multiplying E dividing the mass. This is the charge of the proton and this is the mass of the proton. Okay. In this case we have In this case, we have the charge of the proton. The charge of the proton is the same as the charge of the electron, but positive, okay? And that's why we have the plus sign right here instead of the minus sign. And it is 1 point, is the same as the proton, as the electron, sorry, but with a different sign, times to the minus 19 power coulombs. And the electric field, we found the electric field here, right? Minus 364 newtons per second, newtons per coulomb, sorry, dividing the mass of the proton. The mass of the proton is different and is, by definition, 1.67. You can go to the internet, Google it, or to the books, and you will find that the mass of the proton is 1.67, 3 times 10 to the minus 27 power kilograms. Okay, and the result of this acceleration will be minus 3.49 times 10 to the 10 power meters per second squared. Okay, I want to have something here and talk about it. This acceleration is much less than the acceleration of the proton. So let me write the acceleration of the proton. This is the acceleration of the proton, sorry. I'm talking about the acceleration of the electron. This is acceleration of the proton. This is the acceleration of the proton. And let me write the acceleration of the electron, 6.40 times to the 13 power meters per second squared. So this is the acceleration of the electron, and is much higher than the acceleration of the proton. Just you can see here that the order of magnitude of this acceleration is the 13 power. The order of magnitude of this acceleration is the 10 power. So this acceleration is 3 orders of magnitude higher than this acceleration. So we see that the acceleration of the proton is much less than the acceleration of the electron on part A. So that, what does that mean? What does that mean? So the vertical deflection is less. Why? Let's go to the illustration. The vertical deflection is less, and the proton won't hit the plates. So the proton will leave the region between the plates. So let's go to the illustration and see what happens. This is the electron, right? And this is the trajectory of the electron. The electron barely touched the plates. The electron never touched the plates, but just when it leaves the upper plate, it just leaves the plate, the region between the plates, just passing really close to the upper plate, but they never touch it, right? So that's why we say that the vertical displacement is 0.50 centimeters and the horizontally displacement is 2 centimeters. Okay, because this point is really close to the to the end of the upper plate, to the right end of the upper plate, but never touch it. So, and it has its acceleration. But now we want to have an illustration of the path of the proton. Let's say that we don't have here the electron, we have a proton, okay? Now we have a proton. What we said that the acceleration is much less, okay? That means that the force acting downwards is much less too. And also something that I didn't tell you is this sign. This minus sign means that the acceleration of the proton is downwards, okay? And because the acceleration of the proton is downwards, the proton is moving downwards, is deflecting downwards to the same direction as the electric field. So the deflection is less because the acceleration is less, and it will do something like this. And the electron did something like this. Okay, what is the difference between those two paths? Okay, let me see real fast the part. Okay, we already, let me do something real fast. We already say here, what would the magnitude of the direction of the vertical displacement? Okay, I haven't calculated that. I will do it. Let me do that, but before I will say here, the particle, this is the proton and this is the electron, and see the difference. It goes really close to the upper plate, but this one still has this point, this distance, okay? So that's the difference between those paths, and that is like answering the number C part, right? Compare the paths traveled by the electron and the proton. The paths are like that. So the path of the electron is this one, and for the proton is this one. Okay. Now let's get this part be done and find the displacement of the proton. Okay. So we already calculated the acceleration. And now we can calculate the displacement along the y-axis. So we can use y is equal to y0 plus v0 yt plus 1/2 of the acceleration time square. So we know that this is 0 initially, this is 0, and then this equation is going to be y is equal to 1/2 of the acceleration time square. If we replace the volts that we already know, this is equal to 1/2 the acceleration. We already calculated the acceleration minus 3.49 times 10 to the 10 power meters per second square, multiplying the time that the particle spent to travel through the place, and that's something that we already calculated earlier, 1.25 times 10 to the minus 8th power seconds square. all this is equal to minus 2.73 times 10 to the minus 6 power meters. Okay? Okay, so that's the displacement along the y-axis, okay? And it's downwards because the negative sign that we have here. Okay, guys, the part C is compare the paths traveled by the electron and the proton. Yeah, we already answered that right here. This is the electron. This is the proton. So they are in opposite directions, right? Because the electron has negative charge, the proton has positive charge. They have different paths and opposite directions. So we already answered that question. The displacement of the proton is this. It's something really small in comparison to the displacement of the electron. Actually, if we go to the illustration, we can draw this proton path actually something different, like, because this is the displacement of the electron, right? And that displacement is 0.005 meters, right? And that's something like 5 times 10 to the minus 2 meters, okay? But the proton would be something like this. Actually, the deflection is something like this, and this distance is the vertical displacement, okay? That distance is the vertical displacement, and that's what we got here, minus 2.73 times 10 to the minus 6 power meters. So you can see the difference between the paths and the vertical displacements. And obviously the comparison is already done. That's the part C. And the part D, we already answered that question to discuss whether or not it is reasonable to ignore the effects of gravity, and it's totally reasonable. Okay guys, hopefully you enjoy watching this video. Please subscribe to my channel, give me a thumbs up. It's free to subscribe, and hopefully see you on the next video.